and I'm the applications specialist with AET Labs. AET Labs, if you're not familiar with us, we serve the EDU sector in New England, everything from high schools, tech ed schools, to universities, small prep schools. And we specialize in pretty much everything under the sun with tech education, but specifically digital fabrication like 3D printing, laser cutters, CNC machining, robotics, automation, and more. We also consult on building out new labs with schools, and we love tech ed. So if you do have any questions around other stuff that we do, please reach out to us after the meeting. I'll introduce some of the folks, other folks from AET here, and let them say hello. Matt?
Hey, Matt Campbell. I'm the technology consultant in Eastern New England, so Maine, New Hampshire, Eastern Mass, and Rhode Island. Primarily higher ed, but I do also work with some high schools and community colleges as well.
All right. Dave, would you like to jump in if you're there? All right, you might be on a call, but Kristen, go ahead.
Hi, I'm Kristen. I work in marketing at AET Labs, helping Adam with events and other things that we do to help you guys.
Thank you. We also have a few other folks that may be jumping in the meeting at some point who are the regional sales consultants for Connecticut, Western Mass, Vermont, and also the technical schools in Eastern Mass, Rhode Island, Maine, New Hampshire. Okay, so let me just give you a quick overview of what we got going on today. We are, I'm going to actually pop to the next slide here. So we are just giving an overview of the 3D scan to 3D print workflow using a Creaform 3D scanner and a MakerBot method 3D printer. Now, if you are new to 3D scanning or you're using a different system, some of this stuff will be applicable, some of it won't, just because it might be a different platform. But I think it's a really great overview of what needs to happen in order to prepare a scan for 3D printing. For those of you who are customers of ours and you have a Creaform system, this is going to be a really, really great touchstone for you to go back to and review the workflow specifically with a Creaform scanner and the VX Elements software. What we're looking at now on the left here is the scan we'll be working with today. So we have this really beautiful wooden eagle carving and a smaller scale version of it that was 3D printed on the MakerBot method, which is sitting in the back. The scanner I used for this is the GoScan, which is the Creaform GoScan, which is a high-end scanner from Creaform, very, very, very fast scanner. And it allowed me to make a beautiful, beautiful, well-detailed scan here. But we also offer, more entry-level scanners as well from Creaform. The MakerBot method printer you see in the back, we'll talk a little bit about after we go through the general workflow. While I'm moving ahead, if you do have any questions or I'm going over the software, which is specifically what we're talking about today, is really just the software side of things. Please, by all means, if you want to type into the chat box, that might be the easiest way. I'll enter something into it now. And Kristen or myself will just pause and do our best to address your question. Okay, great. So let's move over to our VX Elements software. Hi, Kevin, welcome.
Hi.
I was expecting you to see you today. That's great. So Kevin, we're just getting started. Kevin actually is up at Dartmouth College, and he has one of our Creaform scanners. Okay, so I'm just jumping right in here. So what we're starting with is we've already captured our scans. Now, the reason I chose to start here is because if I were to really do a half an hour presentation or even longer on everything involved in 3D scanning, it could take an entire day at least. So we're just going to focus on we've already acquired our scan data and what are the next steps. So right now you kind of see a jumble of scans here, which is very common because when we first capture scans, the scanner doesn't really have any understanding of where it is in space. As you can see, there's a view cube down here. If I change angles, it's none of it's really true to the view cube, but we'll get into how we can fix that later. So in the VX Elements software, right now we are in the VX Scan module here, and I have 4 scans that I can, of course, hide or show. And the first thing I want to do is prepare each of my scans for the next step, which is aligning them, cleaning them up, and merging them. And VX Scan has a really nice feature right off the bat that allows me to click Remove Background. And as long as I've scanned, if the area I've scanned on is captured, like this flat plane here, it will find that plane and allow me to even raise the plane up or down, denoting what will be deleted. So once I click Create, it will remove that. One important thing to know when you're working in the VX Scan workflow is that the VX Scan module is a place where all of the scan data is captured. So if I wanted to change my resolution down here to 1 millimeter resolution or 0.25 millimeter or 2 millimeter resolution, I can update this this mesh right here, this rendering, before I turned it into an STL file, which is the file we ultimately will need to create a 3D or use to create a 3D print. For now, we're going to keep all of our resolutions at 0.5, which is a higher resolution. Usually, the entry-level scanners 0.5 is among the high resolutions, and then we start getting more detailed at like 0.2. For this scan, you can see that the 0.5 was really necessary because of all of the details in the carving. Okay. Another important feature here is whenever we delete something in VX Scan, it's permanently deleted. So the work we do in VX Scan is somewhat minimal. We're just doing some preliminary steps to prepare. For example, this little area down here that's kind of hovering by itself, it's okay for me to delete that. I can go in and use our selection tools. I can hold Control and click using the Connect selection tool, and that selects everything that's connected to whatever polygon I just chose. So you can see that this little floating area is, is just kind of sitting on its own. But I can invert my selection, and now I'm selecting anything that wasn't touching the main scan, and hit delete on the keyboard. It gives me a prompt saying it's going to be permanently deleted. I click continue, and I'm just going to move on from here. So I'll hide scan 1, pop over to scan 2, and repeat that process. Remove background, create, scan 3, remove background, and finally this one. And while we're looking at scan 4 here, you can notice that there are some other objects in the scan, and it's actually an isopropyl alcohol bottle and a can of clear coat spray, and I use those to prop the model up so I could get a really decent scan of the underside of its head. And you can see it rendered it quite well. This was a challenging part to scan right in here. And there are all sorts of ways, creative ways you can arrange your objects for scanning. And this is this is kind of a a quick and easy way. Okay, so if I wanted to continue doing work in the VxScan module, I could actually go in and highlight things and use the selection tools. In this case, this is a brush selection tool. If I click delete right now, it will delete the polygons and they'll be gone for good. So I don't want to do that. I'll click clear selection. So at this point, I like to make sure that my resolution is set the way I want it. And then I want to move into the next module, which is called VX Model. And to do that, I can have Scan 1 selected, and then I can click on Send to VX Model in the upper right. And what happens there is the resolution that I had set for Scan 1, which was 0.5 millimeters, is now rendered in VX Model as an STL. So now we have a very light file that we can work with much easier. And when I say light file, what I am referring to is if we look at the size of a VX Elements scan session file right here, we're working with this one right here, and you can see it is almost 4.2 gigabytes. All right, which is huge, right, for something like this. However, our end result will be something like this, which is a 3D object or an STL, and this is just under 20 megabytes. So when you send your file to VX Model, we are just working with a mesh of triangles. And it makes the workflow much faster and more efficient and much easier. So we'll go through these: Scan 2, send to VX Model, Scan 3, Scan 4. And at this point, if I wanted to, I could delete the VxScan module and click Save Session As. And we're going to call this Mesh Edit. And let's take a look at the size of our mesh edit here. We're now at 42 megabytes. This is huge, especially if you're working in EDU. Imagine that you need to share files with students and you are trying to pass along whole scan sessions. It's just not practical. So this is a great way to narrow down your file size and share with a group. Okay. So now we are ready for the next section. We could do some preliminary cleaning on some of these scans if we want. And I will tell you that can get quite involved. That's kind of exploring a lot of some of these editing tools, which we will take a look at. But right now, these scans aren't too bad. So we're just going to go ahead and align and merge them. In order to do an alignment of the different scans, we're going to use the alignment tools up here. And we're going to start with the best fit alignment tool. In the best fit alignment dialog down here, we can choose what model is going to remain fixed in its position and which one will align to that model. And we're going to do one at a time here. So we'll align scan 2 to scan 1. And down here, our alignment mode is automatic. And if we've captured enough similar geometry, in that case, we're talking about if the two scans I'm trying to align, let's say, both have this section of the neck of the bird, or they have this big kind of crevice in the base, they're going to have an easier time doing an automatic best fit alignment because they have shared geometry. And when I click best fit, there you are. Because there's enough shared geometry, you can see they actually overlay each other quite well. Now, let's say they didn't overlay each other well. What's going to happen is it will ask you to kind of abandon your best fit, and it will give you these two view screens, and it will ask you to do a manual alignment. And the manual alignment wants you to manually select similar areas by clicking on each model. And our goal here is to just click in general areas where there is shared geometry. We don't need to do complex geometry. The best, actually, I find, is to find well-defined flat spaces. And the more points we pick, in this case, I just picked 3, you can see on the right view, we've already done a pretty decent alignment. And then I can click best fit. And there we go. We have pretty much the same alignment as we had last time. It might be off a little bit. And if I wanted to, I could reset again, do automatic alignment, and do an automatic best fit. No, actually, no, I take that back. It does look pretty good. All right, so I'll click OK because I want to keep that alignment. And then I'll move on to another best fit where I keep scan 1 as stationary. And now we're going to move on to scan 3 and best fit. Okay. And again, VX Model and VX Elements does a great job of showing us with colors how well aligned our models are. Okay. And finally, scans 4 to scan 1, best fit. Oh, but actually, yeah, well, I suppose I could do this later. So this is a peculiar one, right? Because I included additional geometry here. So this is a good example of something that I would clean up before aligning. So let me hide everything but scan 4. And I really should have done this earlier, and I could have even done it in the VX scan module, but that's okay. So the first thing I'm going to do here is use the Connect selection tool, hold Control before I click to make my selection, invert my selection, delete. And in VX Model is a full mesh editor. Just like you were working in something like Photoshop, I can undo very easily or redo. You'll also see, remember I was talking earlier about how this was upside down so I could capture the bottom of the head. So a lot of this you can see here is very poorly rendered. I didn't spend a lot of time scanning the rest of the model. So if I wanted to just focus on preserving the head area, I can do something like this, use the brush selection tool and use select through, and I'll show you what that is in a minute. So if I use brush selection and draw a line, see, it just selected what we could see, right? So I'd have to go all the way around and select everything. However, if I use select through and draw a line, it selects all the way around like an X-ray. So now when I hit delete, I've just isolated the head from the rest of the body. And I can do the Connect Select tool and select the bottom half and delete it. And I see there's a little piece over here as well, so I can select the head, invert the selection, and delete. And this is all I really wanted to keep. Okay, so now what we want to go back to is seeing if we can do an alignment of scan 4, scan 4 to scan 1. And this is tricky because I just removed a lot of shared geometry between scan 4 and scan 1. So we'll see if the best fit works. All right, and it doesn't. So one thing I could do is I can click reset and try to select some shared points, but really their shared points are few, right? If you look over here, we're talking about like the side of the head. On the other hand, if we look at scan 2, scan 2 actually has a lot of the head intact. So let's try aligning scan 4 to scan 2. And still struggled. So I'm going to click reset and see if I can get away with a manual alignment by clicking on points. Okay, and it looks like it's starting to align over here, so I'll click best fit. And not too bad. Okay, and now all 4 of my scans are aligned. And they are still isolated too. So if I wanted to hide them and work on, you know, editing or cleaning up one of them, that's fine. But I'm going to move forward and we're going to do a merge. At this point, when I click merge in the upper right of our toolbar, I can merge all 4 scans simultaneously. And when I highlight them all, you can see it, it even separates them by color, showing you which areas are most prominent on the scan, which is a really nice feature. The other thing I love about working with this software is I can prioritize the scan. So scan 2 might have been one of the best scans because it got most of the carving. And if I want scan 2 to be high priority, you'll see that it dominates all the other scans. And then the other scans are just filling in the blanks. So here, scan 3 is making up for this area that was not captured in scan 2. Scan 1, which is the bottom, is making up for that area. So it's pretty neat way to do it. Also, it looks like scan 3. Oh, that's just, it looks like it's just kind of isolated over here. We can clean that up later. Yeah, so this isn't too bad. Again, that scan, I think it was scan 4, which was on the underside of the beak. Looks like there's very little of it. It's right here. So if I wanted to, I could put that to low priority. But it's a little rocky here. Let's bring it to high. Yeah, that might be a little bit better. So this is like, you know, this is you know, part of the artistry of the process of, like, you know, working with a scan like this, is you really have to go in and kind of scrutinize it. Well, for now, I'm going to say I'm happy with this. And click apply. I can inspect before I click OK to see how everything looks. And when I press OK, I now have a new mesh called merge. And I can hide all 4 scans and just see the final merge, which is here. And we're one step closer to a 3D printable model. Any questions so far? Okay, so we'll move forward. All right, so at this point, the next step is to clean and polish the mesh. And when I say polish, it's really about kind of just tackling any anomalies we might see, stuff like this, these floating areas over here, holes, rough spots. You can really, there's almost no limit to how much we can clean this up. The first thing I'll do is yet another connect selection and another invert selection. Oh, it looks like it's not going to invert over here for this guy. Yeah, so this is kind of a peculiar anomaly here where there is kind of a rogue streak of triangles that we would manually delete. So I can just do this. I think we got a little bit more. In general, if we do a full selection like this and click Invert Selection, oh, there we go, it did work this time. So now it did invert, and that means it's selecting some triangles I can't see. I'm going to delete those just to make sure that that it's just the connected triangles of the model I'm looking at. And let's move on to doing some cleanup. The first step on cleanup can be the Clean Mesh button right here. When I click Clean Mesh, it pops up a dialog that shows me a lot of terminology that's used in STL language: isolated patches, self-intersections, spikes, small holes, vertices. Narrow bridges is not selected because narrow bridges can often be parts that you're not, that you may want to keep. And what's neat about this is they're also showing you, if you zoom in and scrutinize different parts, they'll show you what errors they're finding with the clean mesh, right? Like here is an open boundary, and this might actually be a self-intersection that's red. And a self-intersection would be like when a triangle's kind of like triangles are folding back in on themselves, which is not good for your 3D slicing software. I'm going to fill up the narrow bridges on this one, and I'll click Apply. And you can see the first thing it did was actually healed that hole right here, among many, many, many other issues. So click OK. And sometimes you might even run Clean Mesh twice, and you might even see some, it might find some more errors, but it looks like we're doing OK. All right. And at this point, I can go in and start filling in the holes. And to do that, I'm going to use this, this tool in the Improve toolbar called Fill Holes. And as soon as I click Fill Holes, you can now wander around the mesh and find every boundary that is not sealed. Now, quick click will close the hole and kind of match the surrounding geometry to the best of its ability. And here it doesn't look too bad. In this case, if I wanted to, because you can see this is a little sharp for the rest of the ridge here, I can click OK, and I can go in and use the sandpaper tool and smooth this out. You can also do some interesting things like where these sharper angles are here and here. I can use my brush selection and just select a small area. And I can click Defeature, which will further kind of match that area with the surrounding geometry. Deselect that. So in this case, this little spike and this little spike, and defeature. And now that's detail work there. But you can see it is much more consistent with one of the better scans or what the actual geometry looks like in the real world object. Okay, back to filling up the holes. So filling holes is going to be common, especially with abstract geometry that doesn't have a lot of, or has areas that are difficult to scan. In most cases, I can come in and just do a single click to fill these up. But in other cases, I may want to be a little more deliberate And let's say this kind of crevice right here, I have the option to fill partial holes on the left here. And what this does, it allows me to select one point and another point on either side of the hole, and then hover over either side of those 2 points and close only part of the hole, which can be nice when you're really kind of trying to keep the geometry continuous. I'm not too concerned about it right now, so I'm going to go back to filling the complete hole. And I would spend a little bit more time on cleaning this up. You know, there are parts in here, like maybe right down here, where it's a little rough. When I worked on this the first time, I used partial fill, and I did a much cleaner job filling this up. But for the sake of time, we're just going to keep it simple. So it looks like I may have gotten all the holes. I'll click OK, and I can right-click on the mesh I'm working with and click on Properties. And the thing I'm looking for here with respect to 3D printing is whether or not the mesh is watertight. Here it's saying no, so that means there's still a hole somewhere. If I want to, you know, try to find that hole, if it's hard to see, I might do clean mesh again. And here we have another list of things that can be repaired. So I'll click Apply. And click OK. I'll pop back to Properties. It still says the mesh is not watertight. So at this point, I'm going to choose Fill Holes again and just do one more look around to see if I can find it. And sometimes they can be, and if you're familiar with you know, working with 3D geometry in the CAD world, they can be hidden, and they might even be inside of the object. And right now, it's very difficult to see if I'm missing anything. So in such a case, what I will do, oh, yep, okay, so over here we have 2 holes missing, and we can automatically select them with the slider. So let's click Apply. We have no idea where they are, but that should take care of it. So now right-click on Merge, Properties, and now we see Watertight Mesh, yes. Okay, all right, our final step preparing this in VX Elements for 3D printing is to do a align to origin. So now we want to align it so this view cube is representing, or I guess, you know, it would be this view cube is kind of the shared sort of coordinates as your 3D printing software. And right now, if we look at a side view with Z pointing up, we're looking at the bottom, so that's not right. So the first thing we want to do is we want to create an entity. In this case, we'll go up to the Entities toolbar and we'll create a plane. And when we move into the plane parameters, it automatically chooses the similar normal selection tool, which means whatever triangle we click on, it's going to select a bunch of triangles that's similar to it and give us a color map showing us deviation based on the triangles that are selected. And you can see that most of it is looking good and within a deviation of negative, let's see, I think -1 to +1 millimeters, so within 2 millimeters, which is pretty broad, honestly. You can change that deviation if you want, but for now, I'm comfortable with it. So I'll click OK, and there is my plane. Cancel will close the window, and now I can see my plane, and in the browser navigation window, I can see under Merge and this is very similar to CAD software in general. When our browser tree starts populating, we have entities now and plane, which we can hide or show. Using manual alignment in the upper left, I can now say I want to use the plane one that I just created, and I want to constrain it to the XY origin plane. And right away, I already see a huge difference. I can actually click on the view cube and start to see that it's looking a little bit better as far as you know, a grounded coordinate system in digital space. But it's also kind of flipped upside down. So our Z is pointing up, but the bird's pointing down. So what we can do is we can flip our the normal of our plane, and that will bring the bird right side up. So we're good on the XY plane. We can actually change our rotation orientation if we want as well. And by doing that, I'm going to just click on the view cube to give us a top-down view. And I can click on the blue circle in order to do a rotation on XY. In this case, let's say I want the bird's head to be looking forward on the X axis. I can just do a rough movement and get that positioned. When I click OK, I now have a partially aligned model. And that is everything you need to do to prepare for a 3D print in the VX scan to VX model workflow. All right, and also we can go around and get a nice even view of our model. So since we're looking good over here, I can, first of all, I'm going to save this. So I'll save my session. And I'll call this, I could call it mesh edit. And because it's such a small, light file at this point, it's a quick save. And I can right click on my merge and export mesh. And call this wooden eagle scan aligned. And this is exporting as an STL, but you can see there are many options here. Some of them working specifically with different platforms. And one really wonderful thing that we're not talking about today, but I'd love to just bring you up to speed on at some point, is that these scanners that I've been working with will capture texture, as in color. So when I did this scan originally, this eagle was in full color. And Kevin, I know that that's something you want to do. Kevin has a multicolor 3D printer from us, and he's done some really beautiful prints. I'm hoping to do another Tech Tuesday where I actually focus just on that side, where we talk just about you know, color scans and how to manipulate that side of things. Okay, so export mesh, do this again, sorry. Eagle. Okay, and now I can double check this quickly by opening the file in Windows 3D Viewer. And if I did everything right, I should see it aligned in the Windows 3D Viewer. Estimated cost. Interesting. I'm not quite sure if, like, what that's referring to. That's the first time I've noticed that. But yeah, this is a good way to check that. But what's more important is we need to move on to MakerBot. So what we have open now is MakerBot Cloud Print. And again, we are prepping this model for the MakerBot method. And a big difference with the method is that is a dual extruder printer. I'll show you some actual images, but first let's just continue through the workflow here. Let's see. All right. So I am connected through CloudPrint to our demo, AET demo method here. You can see it as a camera, which is a nice feature. And I can click on New Print. And because the method's a little bit more of an advanced desktop printer, it has spools of filament with chips in them that will tell you what filament is loaded and how much is left if we navigate to some other settings. But we are connected to this printer, so at this point, I can go in, drag and drop my wooden eagle scan. The first thing it's going to tell me is that it is too big for the printer, which is what I expected. So I can click Scale to Fit. And I would probably shrink it down a little bit more. And you know, MakerBot is always focused on making their interfaces very user-friendly. So if I wanted to scale, I'll click on this button here, and I can choose dimensions or percentage. I'll click uniform scale, and let's do 50%. If you are someone new to 3D printing, or you're 3D printing with desktop printers that print a single material, you may wonder what this little square is over here. This is what's called a purge part, and I'm going to show you what that does in a second, or what it's for in a second. But for this print, this will take a very, very long time if I have it oriented upright like this. So it is more practical for me to orient. I'll try Smart Orient and see how that does. For me to lay the bird on its side, and it'll print a lot faster than printing all the way up as high as it is. In this case, because you can see it's taking a little while, because it's a relatively abstract model, it may not do the best auto orienting it, but there's nothing wrong with that. We can just do a simple orientation of you know, rotating it by 90 degrees. And I think I'm probably going to do that. Yep, so let me just start over here. Okay. That's not what I want to do. There we go. Okay, so I'm comfortable with this orientation. Now, if you know, I might do X a little bit here. Oh, now I'm getting it all over the place. Hold on. If you are, you're familiar with the desktop 3D printing process, or printing with a PLA commonly, you're going to get supports that you have to clip off or break away from your model. It's a messy procedure. It takes a long time to clean up. With this model, or with this printer, I should say, we have a dissolvable support that gets printed with our model. So let's take a look at what that looks like. All right, while this is slicing, because again, if it's a model that has a lot of geometry, it could take longer. If it requires more support structure, it could take longer to slice. Let's take a look at this slide. So when I talk about soluble support, this is, interestingly enough, if you look for images like this, they're rare to find. A lot of people just show the models, but I love sharing images like this because this is what it looks like when you print with a soluble support. In this case, we're looking at the white support, which is PVA or polyvinyl alcohol, a really fascinating polymer that has, is used or derived partially from alcohol. So when you put it in a water bath, it'll dissolve over time, and then if you put it in a moving, like something that has agitated water, it will dissolve even faster. These are very small models, as you can see off to the right. The hair clippers guard attachment is like kind of a precision piece that needs to mechanically interface with something, and it came out really, really well. These are 0.2 resolution prints. And the one on the left was a sample I made to test the tolerance of printing a mechanical assembly all in one print that would move after the support is dissolved. And in this case, you can see right here, this is, I believe, 2 beads or 2 layers of 0.2 millimeter support. So the distance between the top of the gear and the underside of the housing is 0.4 millimeters. I think that's what it is. It's possible it's 0.2. Now that I think about it, it might be 0.2. But I really pushed it to the limit to to just see how it worked. And the only thing that, interestingly enough, with this model that I struggled with was there is in the gear axle that would be under here. There is support that gets printed in there, and it was very hard for water to access that area. So I ended up redesigning this and putting holes in the face here for water to get in and help dissolve that, which certainly helped. Here we see my at-home solution for dissolving the soluble PVA using a container I bought from Target and a fish tank pump, water pump I ordered from Amazon for like 15 bucks. This mesh fence right here, I designed in Fusion 360 and printed on the MakerBot method, and it does a great job. Off to the right, you can see just a little comparison I did of after some hours, probably like, it might have been like I left these like running for probably 4 hours before I returned home, but after that time, this is how much support was dissolved off of the back of the eagle print in the still water, and this was in the moving water bath. You can see it did a really good job. All right, let's see if our slicing is done over here. Yeah, here we go. Okay, so what we're looking at here is a rendering of the support material and the model material. Which we can, and as most slicing software does, we can preview layer by layer to understand really what's happening here. And yeah, you really can't you can't beat like 3D printing a abstract scan model like this. If you try to print something like this on a standard desktop printer, it is wildly different because of the supports you have to take off. You just get a really good looking print at the end of it. The Purge Tower over here, which it consists of both support and model. Its job is because when it switches, when the 2 extruders swap in the machine, you imagine that when it stops printing support, it has to retract the filament back up and then cool it down so it doesn't drizzle out. But then when it switches back to print support again, it needs to heat that up and start pressing out the filament again. In order to do that efficiently, the Purge Tower is their solution to this, and it works really, really well. Sure, it's wasting a little bit extra material, but it's well worth it for such a quality print. Yeah, and from here, you know, you can get into the back end of settings if you wanted to with MakerBot. They've always been famous for allowing you to change every single setting on Earth with respect to the print, but in this case, we can just click on print, and I can click start print, which I'm not going to do right now because I already have 2 of these guys. Okay, I know I rushed through everything, but what's great is there's going to be a recording of this available, and we are running to the end here. So I love to open the floor to any comments, and you are welcome to unmute yourselves and jump into the conversation for the last 5 minutes. And I appreciate y'all sitting through that. Kevin, I think you're muted. Kristen, can we unmute him?
I don't think I can on my end. It looks like it's saying that he's unmuted.
Oh, I can't see it over
How
here.
about that?
Okay.
There we go. Yep, I
Right.
got it.
Okay, well, thanks so much, Adam. It's really very helpful. And it's so convenient that you record these so that I can share them with students out here going forward.
Yeah.
So that's really very helpful. I had invited half a dozen students to log on, but of course, things are heating up for them academically. So as I say, recording is really very handy. So I'm especially looking forward to capturing texture and color on these so that we can print them on the J55 in all their glory. And so that's where a lot of the appeal comes from. And I'm also excited about the impact that this whole process can have for students designing with shapes you can't draw in CAD, you know, to get them in, you know, things especially ears, foot, feet, arms, you know, hands and so forth, so that they can design around these objects that get scanned in.
Sure.
Going forward. I'm also really interested in hearing what other academics are doing with these tools. I really feel as though the future of design is in these complex geometries going forward.
Well, Kevin, let me, if I may, just, I know because we're short on time, but I do have one other slide that we put together here that touches on some kind of wild applications. So Matt Campbell, who is in the meeting with us, Matt and I go out frequently for demos of these scanner systems. And we have just, like, I think we both have really been kind of blown away by when we do the demo and Matt asks the question, what's your goal here? What do you want to do? So let me share this slide with you. We just summed up just a few applications that some universities are doing out there.
Yeah, and briefly, maybe you can let me know if we can export the 3MF file formats here. That's really a convenient way to capture color and texture.
It is, yeah. I don't think you can. I don't think you can do 3MF with this system, but you can do VRML, and that is, you know, which is probably one of the more common ones that before 3MF. But there are options for sure. Okay, so yeah, so this is just 3 samples, all different schools that Matt and I visited. So much fun to learn about what these schools are up to. So, and Matt, correct me if I'm wrong here. Marine biology was Northeastern Marine School, yeah, in Nahant. Yep. So we visited them, and they said we want to scan starfish because a couple of reasons. We want to, in order to determine a starfish's age, you have to measure these spines, which are these bumps right here. And how are we doing that? You know, it's a really difficult process. They also wanted to scan living starfish. They wanted to try to, you know, do understand the age without having to use dead starfish. So I made a little demo here, and we can see it in the image where I scanned a starfish, and I created a cross section right here, representing where the crest of the spines are. And then I drew a line that kind of follows the contour of the arm of the sea star without these spines. And in this case, you could do a dimension, like a very simple metrology application of measuring from the base of the spine to the top of the spine. Archaeology, and yeah, Matt, I think we might be at a loss for this one, but this was a school that wanted to. It's kind of hard to explain, but in this case, digitally assemble broken ancient artifact fragments, and more specifically, they were unearthing. Like there's a word for it, but the kind of broken shell components of a mold, like an ancient mold, like how our ancestors would mold things. So they wanted to scan the fragments and in order to assemble them back together. Does that sound about right, Matt?
Yeah, that sounds about right. It also kind of ties in with the one we did with the Worcester Art Museum. That was a pretty cool project if you want to touch on that.
Oh yeah, yep. Yeah, so that one that Matt's talking about was a large kind of like supersized sculpture of a like a woman laying down made out of marble, was missing a lot of digits, so missing like toes and fingers. And what they ended up doing, and they actually went through the process, is they scanned toes and fingers that did exist on other hands and feet, and then they inverted the scans and 3D printed them and attached them to the missing parts. So that was pretty cool. And the last thing we've probably seen more than anything is engineering metrology, comparing machined part dimensions to original CAD models. So in this case, one interesting example was it was a lab that was developing radar dishes that would get affixed to a vehicle, like a surveillance vehicle, and they wanted to know if the radar dish, the machined radar dish, was accurate to the dimensions of the CAD model. And you can do this with 3D scanning software like VX Elements. So, yeah.
And one other component that we're interested in, as you know, I had commented on getting the resolution that we selected for our Academia 50 was the the larger part size. That is, it started with part sizes essentially like 6 inches to 24 inches or something like that. And the museum is interested in having us scan smaller objects with a finer resolution, which requires another scanner. So I don't know if or when we're going to get around to being able to fund another $10,000 scanner, but if there's a technique for capturing the kind of detail that you find on ancient coins and so forth, that's of interest with our museum. So.
Yeah, I mean, Matt, Matt's your guy to talk to about this because he's really dug into the deeper side of like what Creaform offers. But I know that they do have these really fine detailed scanners that can capture what you're talking about. But yeah, unfortunately, the one that you have, if you're talking about a coin the size of like a nickel, for example, yeah, I mean, believe it or not, you might be surprised, but it probably won't be at the detail that you'd be looking for. The last thing I'll just share on the application side that I frequently talk to. Oh, hello. Do you have a question or a comment?
I do. Well, first, yeah, comment. Thank you for doing this. It's really appreciated. I wrote a grant to get one of these, and I'm just kind of waiting for it to waiting for the grant to process so that we can get order and hopefully before the end of the school year. But my question is, and students ask me this all the time, can it scan their face? I guess that's what they do. Can it do that?
Big one.
Is there an issue with, the eyes or whatever?
Yeah. So one of our teachers who has this scanner, Matt, it's I think Belmont Hill School.
Yeah.
So they just sent that question over to me, except it was with regard to the hair. So they were scanning students, and they said the hair is not coming out. With the entry-level Creaform scanners, when you hit reflective surfaces, you are going to the light's going to scatter, and it's not going to accurately capture a surface like that. So in most cases, if you see reflection, if you see light glistening off of something in a way that it doesn't typically glisten off of like my shirt, but might on my forehead or my nose, then yeah, the scanner might struggle a little bit for that. For eyes, you would be, you would be at a loss essentially, and certainly you wouldn't want to shine the scanner light in someone's eyes, anyways. But yeah, having them close their eyes is fine. And then if your students are adventurous, the kind of showstopper is when you use a powder spray. In this case, Matt and I will bring Dr. Scholl's powder spray with us. And when you hit something that's reflective with that powder spray and then scan it, it changes dramatically. Like all of a sudden it's capturing it great. So the teacher at Belmont Hill School asked, and I said, hey, if you want to spray powder spray into your student's hair, you can give it a try.
Or they could wear a hat. We've done that before as well.
Or they could wear a hat.
We've actually scanned people's head at a trade show and 3D printed it in the same setting. So yes, that is possible, Joe.
Yeah, that's actually, that might be less intrusive.
Yeah, I guess a follow-up to that is this comes with training, I understand. And so when the scanner comes in and it arrives at my school, do one or both of you come up and train me and train my students and go through this whole process?
Yeah, so Joe, that would be me. We don't train students typically. The goal is to onboard the teachers and the teachers to move on from there. However, it's not unheard of, mainly I kind of I put a threshold on that just because I want to make sure that all of a sudden I'm not teaching like 20 students. But I have had a couple of students join us before. So I did work with one teacher who asked me, Adam, do you mind? I have 2 really bright students that are definitely going to take this on. They're going to teach other students. No problem with that. No problem with that at all.
Is that a 3-4 hour session? How long do I plan for that?
It's usually it's packaged with it's roughly a day. So we're talking about like a total of 6 hours. Now, whenever you see like training on an order from us, we're very flexible with respect to kind of parceling this out. What I end up doing usually is doing a half day. If the teacher wants to do a full day, we can. And then I will let them experiment a little bit, and then we'll follow up with a remote call. Because covering the hardware stuff is, that has to happen in person, but it's pretty straightforward. The software is where a lot of the action happens.
Okay. Thank you. Appreciate it.
Yeah. Yeah, Joe, I hope that, I hope the grant comes through.
Oh, the grant came through. It's a matter of it's done. It's approved and everything. It's just
great.
a matter of us processing it.
Gotcha.
Our end at the SAU, and then I'm assuming in the next couple of days or week that we'll be able to create a PO and order it.
And Joe, you have some other stuff from us, don't you?
I've got a few things. Yeah, I wrote a grant for an F-170 and a 123 demo, I believe it is, and they're coming. The POs, you already have the POs, so they're coming soon. And
Excellent.
I've got MakerBots.
Yep. You said you have a U-print?
Yeah.
Yeah. And I mean, I just like the U-prints, one of they're like legacy machines. I always pop in schools and people have U-prints going and they just seem to last forever. So that's great.
With a little bit of TLC, yeah.
A little bit of TLC, of course. Well, yeah, I mean, 3D printers, sure. Yep.
Yeah.
Great to hear. Well, I'm looking forward to working with you for sure.
Same. Thanks.
Okay, well, if anyone, Julie, if you have anything you want to say, this is all good. All right. You're muted, Julie.
No, I'm just taking it all in. So learning as we go. We're new to this. So, and again, and I know you guys, your scanners and things, we don't have big budgets. Our school doesn't have a lot of big budgets, but we're going to try to work with that RevPop. And again, that's kind of inexpensive, but for high school. So we'll just learn as we go. So who knows, unless I can win the lottery and I can get some of these big high-end stuff. But for now, I appreciate you offering this to learn.
Sure. And Julie, if I may ask, where are you located? What school?
I'm Whitman Hanson on the South Shore of Massachusetts.
You said that. South Shore, okay.
Yeah.
Okay. Well, I mean, I guess, since you already are getting into the scanner, if you did want to chat more on 3D printers, you can always reach out to us.
Okay. Where are you guys located?
Well, our home base is Essex on the North Shore, but we are all over the place. Like, Matt is near the Boston area. I'm in the Worcester area. We have one of our colleagues is in Connecticut, like Southern Connecticut. So we're all over.
Okay, great. Super. Thank you for
All
your
right,
time.
folks.
Okay.
Yeah, thanks. Kristen, thanks always for helping pull it together.
Thanks, Adam.
All right, guys. Take care.
Yeah.
Till next time.